Sorry we cut off there a bit. Not very professional, but I'm working with what I can right now. So in part D, we're looking at what does that derivative represent? And I just rewrote it in black here. Okay, there's the derivative we were given. But you know what? That does represent the change in the population, the derivative of p. So I wanted you to think of that as, oh, dp over the variable we're looking at. The independent variable is time. So this is just a fancy way of saying, oh, when the time is 8, that means in 1988, 8 years after 1980, the population was growing 2,500 people per year. dp over dt, since p is in thousands of people and t is in years, that tells us it's changing in thousands of people per year. In part E, we're looking at the signs of these. And it's really important to recognize that, hey, this is representing a specific time. We're not just looking at the derivative anywhere. When we see that t is equal to 1, we're talking about the year 1981. Was the population changing in a positive growth rate or a negative growth rate? Was it getting bigger or smaller? Well, actually, up top in the description of the problem, it said that the population is increasing up until about 1995 when it hit its peak. So if we wanted to know how the population's changing in 1981, it's growing. It is positive. The answer to part E for the first one is positive. Likewise, when you're looking at the next part where t is 20, that's the year 2000. And it just so happens that in the year 2000, guess what was happening to the population? Now it's going down. It has a negative sign. That brings us to the very last problem, part F, and that is I'm asking you to actually estimate the derivative there at 15. Go ahead, take a second, try that. Because that is just a fancy way of saying what is happening to the population, how is it changing in 1995? And when you hit a maximum point, a maximum or a minimum point on a graph, really, but we're talking about a maximum here, guess what we know about the derivative? That's where we have a horizontal tangent line. That's where, for a split second, there is no growth, there is no decrease. For one moment in time, the year 1995, when it hit its maximum population, the population was not changing. It wasn't getting bigger or smaller. As soon as 1995 is over, the population is decreasing. Everything from 1980 up to 1995, the population's increasing. But right there at the highest point, there is no slope. It's a slope of 0. Excuse me, there is a slope. It's a slope of 0. That's the interpretation of this. You can do this for anything. So you have to look at the words to see what the units are. You actually have to read the problem and interpret. I'll give you a few more problems to work on in class. Good luck.